Hi, thank you for watching Math with Mrs. Lehman. I'm here with my very positive third period class today. All right, we are going to continue lesson 28 today, which is all about percents and understanding that percents are out of 100 and whatnot. So we do have a test coming up on Friday, and it's going to involve all things Module 1. So our bell ringer is a little review of something that we learned, I don't know, was it about a week ago? Or maybe 2 weeks ago, I'm not sure, but you're solving for the distance. So it says Mrs. Polly drove to her daughter's house. She drove 60 miles per hour for 2.5 hours. How far away does her daughter live? So this is the rate of speed. This is the time. We are looking for the distance. So we're just going to plug in the numbers. What can we plug in for rate? What can we plug in for rate, Kaylin?
60 miles per hour.
Very good. 60 miles per hour. And we're going to multiply that times what for the time? Amaya? 2.5 hours. Yep. So 2.5 hours. Now if it said 2 hours and 30 minutes, we'd have to convert those minutes to hours, right? Because it's miles per hour. So in this case, you weren't being tricked, but beware of that in the future. I know on your test you have at least 2 questions involving distance, the distance formula, so make sure you commit that to memory. Distance equals rate times time. It is not given to you on your 6th grade reference sheet, so when you get your reference sheet for your test, make sure you just write that down immediately. D equals RT, okay? All right, so now we just have some multiplication to do. So I'm going to set this up. All right, 0 goes there. 6 times 5 is 30. Carry your 3. 6 times 2 is 12. 12 plus 3 is 15. Now, a lot of kids struggle with where to put the decimal point, and a lot of kids mistakenly think that you just drop the decimal point down, okay? In this case, coincidentally, it ends up in the same spot, but the reason why it's one spot over is because you count up all of the places, decimal places that there are total in that problem, and in this case, there's only one, so you move it in 1, okay? So the answer is 150, and what would my units be here for the distance? Calvin, nice and loud. Miles, very good. And the reason why it's miles is because you cancel out those hours, essentially, when you multiply across there, and you are just left with the miles. Any questions on that? Okay, we're going to move on to what your homework was last night on page, was it 92? 92. Okay, so we're finding out the price of this outfit. All right, and we already did the price of the shirt, which started as $44. We got $11 off of that. So we added another row here that said sale price. And the sale price is the part that you are paying. Okay, so if you had an original, 100% of the cost was $44, you saved 25%, that's $11, you would end up paying $33 for that shirt. The pants, we said that the 30% savings, they were originally $50, we figured out. We saved 15, and we are paying 35, right? And then we also together figured out the price of the shoes, right? We did the shoes together in here. All right, so those were $60 originally. If you are saving $9, that means you are paying $51, okay? So your homework, at least for this class, was to figure out the necklace and the sweater, okay? So when I checked the homework, I noticed a lot of kids were not very good about labeling their work. So make sure that you have each section of this labeled. In this case, we're doing the necklace. We know a few things here. We know that we're saving 10%. We know that the original price is $20. So we're looking to set up a part over whole proportion. And we know that's percent out of 100. So we're going to plug in what we know. The 100 is free. All right, and we know that the original price goes across from the 100%, right? Because that's 100% of what you would pay if there were no discount. So in that case, it would be $20. Okay? And then we also know we saved 10%. So I want to point out this percent is the percent we saved, right? So the discount is the amount of money we saved, not the amount we paid, right? The amount we paid will be the sale price. What was that?
The save price go on top.
Very good. Yep. So the part goes on top. In this case, we just have to make sure that the saved amount of money is across from the saved percent. And we'll talk about where this changes in a minute. All right. So we're going from 100 to 20, and that's easy to do. We can just scale that down. What do we have to divide by? Everyone? By everyone, I mean apparently 3 kids. So we divide 100 by 5 to get 20, right? To get from here to here, take 10 divided by 5, you're going to get what?
2.
2. So we saved $2. The original price was 20, so that means we're going to pay how much, everyone?
$18.
$18. Good. All right, any questions on how to set that up?
Could we simplify the 10 100?
Yes, of course. Yep, so Cadence wanted to simplify this, and she went to 1 to 10, and she said 10 times 2 is 20, 1 times 2 is 2. That's perfectly fine, okay, as long as you keep it proportional, either way. What you need to do is take that ratio, scale it down sometimes, or it won't necessarily scale up to what we need it to. So sometimes it works out. If it doesn't work, as long as we keep it equivalent, we can then use that to get it where it needs to go, if that makes sense. The last one you had was a sweater. So same setup. Part over whole equals percent, bless you, out of 100. And we know percents are out of 100. We know we are saving 20%, and we are saving $7, right? So that's why that goes across. We don't know the 100% retail value. Now to get from 20 to 7, that's not going to work out too well, right? So we need to simplify this. Now, really your only choice in this case is to go to simplest form or lowest terms, which is what, Kaylin?
1/4.
Not 1/4, 1/5.
Oh, 1/5.
Because 20 goes into 100 5 times, okay? So 1 times 7 gives you 7. 5 times 7 gives you $35. So your original price is $35. You're going to save 7, so that means you must pay how much?
$28.
$28. Very good. All right, so I want to take a second and show you how this kind of works, because the next problem we're going to talk about talks about this type of thing. So on this shirt, for example, we saved 25%. So what percent did we pay? Ava?
75%.
Very good. So 75% of the retail price is $33, right? So the pants, if we saved 30%, what percent did we pay?
70.
70%, very good. If we saved 15%, what percent did we pay? 85%, good. If we save 10%, what percent are you paying?
90%.
Very good. If you save 20%, you're paying 80%. Now, I'm going to show you how this works. Let's use the necklace. We'll go with the necklace. Okay, so we know there was a 10% discount. So maybe they said that instead of telling us, what did they give us for that one? They gave us the original price. Maybe they said that the sale price was $18 and we got a 10% discount, right? So maybe they said sale price $18, 10% discount, right? Now, a lot of kids are going to try to set that up, and they're going to put the 10 over 100, and they're going to think that they are magically going to solve this. All right, so we know percents are out of 100, but now we know the percent discount is 10%, but we don't know the percent saved, or the money amount saved. We know the sale price. So this is the part what? Saved or paid?
Paid.
Part paid, right? So we want the percent paid over here. If we got a 10% discount, what percent did you pay? You already said that. 90%, right? So 90% is what you're going to have to pay. So 90 out of 100, again, this 90 is a percent you paid. We know we're paying $18, so we need to know what the original price was, right? If you simplify this, you could do what Cadence did, just chop off a 0, right? You can get 9/10. To get from 9 to 18, you multiply by 2. 10 times 2 will give you $20. So again, you could have solved that same problem if they had given you different amounts. It's all about the setup, okay? And understanding that I'll do that in a different color. Let's say this section that I'm putting in green, right? These all have to be the part paid in this case. And this bottom part has to be all the 100% retail value original price, right? We're up here, these are percent saved, and the 100% info doesn't really change. All right, so sometimes if you're given info that you're like, I don't understand where to put this, you got to make sure that they align, okay? Part paid is going with the percent you paid. All right, let's look at the next problem. They give an example on the next page, and this is actually an exit ticket from lesson 27. And it says Jane paid $40 for an item after she received a 20% discount. So this is the part paid, right? We call that the sale price, right? And that is the part you're going to pay. All right? The 20% discount tells us what she's going to save, but we're going to need the part that she's paying, right? So we need the percent that she's paying as well. What percent is she paying if she received a 20% discount? Well, Lola?
80.
80, very good. So she's paying 80%. Jane's friend says that this means that the original price of the item was $48. Well, we're not going to use that info, okay? Before you are getting too involved in trying to figure out what someone else did, I want you to think about what you would do to do it properly first. I really hesitate to show you the incorrect way to do something, right? Because this person did it incorrectly. So we're going to do it correctly, just like if a teacher were grading papers, they would have their key made before they check the other kids' mistakes, right? So this is going to be under part B for you, where you're going to show this work, okay? So I'm going to write it under part A just because I need, I don't want to be scrolling back and forth, okay? So you're writing it under part B. All right, so we're going to do that whole part over whole equals percent out of 100 thing. Okay, we just got to make sure all of the things correlate. So we have 100% over here. That's pretty easy. And we know that she received a 20% discount, but we also know that she's paying $40. So let's focus on the money here. She's paying $40, so that goes here. And that is the part we said that she's paying. So what percent do I need to put across from the part she's paying? People are whispering it, but 80%, right? Now we don't know what the discount amount was, and we don't know what the original price was. That's why I chose to put the part paid, all right? Because I would have too many blank spots over on the left if I were to use a 20% discount. Make sense? I would end up with something I couldn't solve then, so I have to use what I know to figure out that's $40 is 80%. All right, now to get from here to here, this is pretty easy now. To get from 80 to 40, we do what? Divide by 2. 100 divided by 2 is $50. So the original price is $50. So down, you're still under B, but I'm going to scroll down here. Is her friend correct? No. The original price All right, we're gonna practice the same concept for your homework, and you guys are like way ahead of the other class apparently, because we did not get to all of this. Page 94, if you could look at that, please. We're gonna get set up for your homework, and maybe you'll have time to get a lot of it done in class, okay? So, so the lesson summary, this is kind of the big idea of this lesson. Percent problems include the part, whole, and percent. When one of these values is missing, we can use tables, diagrams, and models to solve for the missing number. We used what? What have we been using to solve these?
Proportions.
Proportions, yep. So, all right, let's look at the first problem here on the problem set. Question 112. It says Mr. Yoshi has 75 papers. Okay, that's his total number. He graded 60 papers. He had a student teacher grade the rest. What percent of the papers did each person grade? All right, let's read that again. Mr. Yoshi has 75 papers. He graded 60 papers, and he had a student teacher grade the rest. What percent of the papers did each person grade? So we're looking for a percent here now of 2 people. All right, so we're going to use part over whole equals percent out of 100. Oh, okay. All right, so we've got to figure out what we have here. What can we fill in? 100%, somebody said. Okay. We know 75 papers. Now, will that go on the top or I can't talk today. The top or bottom, Calvin? Would that be the partial amount or the whole amount? The whole amount. So we're going to put that across from what? 100. Yep. That represents all that he has to do. Okay. Now we know something else. We know 60. Where does that go? On the top. Very good. That's the partial amount that he has done. All right. We're looking for the percent, so we're going to draw a blank box there. All right. I'm going to have you guys solve that yourself in a minute, okay, during work time. Remember, if you can't divide or multiply, you must simplify and then use that to scale up. Now, remember, it's asking not just for the percent Mr. Yoshi graded, it's asking for the percent both of them graded. So I expect you to say something to the effect of Mr. Yoshi, I cannot even write today. Oh boy, okay, it's a Monday. Mr. Yoshi graded blank percent, right? And the student teacher graded blank percent. What should those 2 percentages add up to?
100.
100, very good. So you could either set up another proportion for the student teacher, right? How many papers would the student teacher have to grade if Mr. Yoshi's done 60 of them? Haley? 15, very good. So you could set up another proportion and solve it that way. Or once you find Mr. Yoshi's percent, what could you do? Amaya? Very good, Amaya, subtract that from 100. All right, so you have options. Let's go to question 113 and get this set up. It says Mrs. Bennett has graded 20% of her 150 students' papers. So she has 20% done. She has 150 total to do. How many papers does she still need to finish grading? So again, you're going to write part over whole equals percent out of 100. Now, where are we going to put the 20%? Top. Now, that's the percent that she has graded or yet to grade? Graded. So this is what represents the graded papers, right? She has 100% to do, but she's got 20% done. Now, we know 150 goes where? Sulima. On the bottom. Very good. So 150 papers total, and we want to figure out the percent that she has or I'm sorry, we know it's 20%. We want to find that in papers. How many papers does she have to grade? Now, is that going to give you your answer? If you find the number of papers she graded. No, it's not. What are you going to have to do to find the number of papers she has left to grade?
Subtract your answer from 150.
Very good. Very good. All right, so I'm going to let you guys use the rest of the period to work. I'd like to thank all the viewers for watching. Please don't forget to like and subscribe, and have a great day.